In this video, we're going to do an example where we see lots of different definitions and formulas associated with probabilities. So, let's suppose we have events A, B, and C, and that we're given that the probability of the union of the three events is 0.99, the probability of event B is 0.4, the probability of event C is 0.75, and the probability of C given A is 0.3. Further, we're told that A and B are mutually exclusive and that B and C are independent. We're asked to find the probability of A and the probability of A given C. So let's first start with the probability of the union of the three events. We're told that that's 0.99. We can break up that probability as the sum of the individual probabilities of the events minus the probability of each of the pairwise intersections plus the probability of the intersection of the three events. We are told something about the probability of C given A, and we're told something about the probability that B and C are independent, which tells us something about the probability of B intersects C. All right, first let's worry about the conditional probability. All right, so we have the probability of the intersection of A and C. We can rewrite that as the probability of A times the probability of C given A. We're told that B and C are independent. That means that we can write the probability of B intersects C as the product of the probability of B and the probability of C. So now let's just start substituting in some values that we know. We're told the probability of B is 0.4. Probability of C is 0.75. This 0 comes from the fact that we're told that A and B are mutually exclusive, so the probability of that intersection is 0. We don't know probability of A, but we do know the probability of C given A is 0.3. And again, we know probability of B and C, so we can plug in those values. And then finally, the last one here, again, since A and B are mutually exclusive, the probability of A intersect B is 0, so certainly the probability of A intersect B intersect C is also 0. So now we can solve for probability of A. Simplifying, we get 0.7 times the probability of A is equal to 0.14, or the probability of A is 0.2. Now that we know the probability of A, we can figure out the probability of A given C because we have enough information. Using our formula for conditional probability, the probability of the conditional is the probability of the intersection over the probability of the given. Now we also know that the probability of the intersection we can rewrite as the probability of A times the probability of C given A over the probability of C. And now we can plug in the values since we know all of these three. Probability of A we found was 0.2. Probability of C given A was 0.3, probability of C is 0.75, and simplifying you get 0.08 for the final answer.